Welcome to Spring LIB.
So to write down the balanced net ionic equation for each reaction, first you have to write down the balanced molecular equation. From there, we'll have to find out total ionic equation, and from there we can find net ionic equation. So let's start with the first one, where we have chromium sulfate reacting with um, ammonium carbonate. So the products of this reaction will be chromium carbonate, which is Cr2 CO3 3, that will be aqueous. No, so since it's an insoluble compound, since most of the carbonates are insoluble in water, it will be in solid form, and we will have um, ammonium sulfate, NH4 2SO4, and this being soluble in water, it will be in aqueous state. Now we have to balance the equation. Let's first balance the metals. So we have chromium, two chromium here, two chromium here. Then if we go for the cations, we have um, two ammonium here and two ammonium in the product also. Then we have three sulfate in reactant, and we have one sulfate in the product. That means we have to multiply this by 3, and now we have 6 ammonium here. That means we have to have 3 ammonium here, and now we have 3 carbonate here, and we have 3 carbonate here. So if we just recheck our calculation here, we have 2 chromium in both sides, then we have 3 sulfate in both sides, then we have 6 ammonium in both sides, and we have one carbonate, or 3 carbonate in both sides. So that is our balanced molecular equation. From here we have to write the total ionic equation. So the total ionic equation for this reaction will be Cr3 plus, and we have 2 Cr, that means it will be 2 Cr3 plus aqueous plus 3SO4 2 minus, since we have 3 sulfate here, and we have 6 ammonium, and we have 3 carbonate. And in the product side we will have, so since it is a solid product, that means it will be remain as neutral molecule, it will not be ionized. Cr2 CO3 3 will be in solid, and then again we have 6 ammonium and 3 sulfate. Now if we just cut the common or spectator ions on both sides, which we have to identify also. So let's identify our spectator ions, or the ions that are common on both sides of the equation. So the common ions here, we can see that um, we have 2 chromium ion on this side, but here we don't have any chromium ion. Then we have 3 sulfate here, and we have 3 sulfate here. That means our sulfate is a spectator ion, and our and then we have 6 ammonium here and 6 ammonium here. That means ammonium is also a spectator ion. And finally, we have 3 carbonate, but there is no carbonate ion present in the product side. That means our spectator ions here are sulfate ion and the ammonium ion. And while writing the net ionic equation, we will just simply cut these two and we'll write the rest of the ions or the solutes or the particles present. So the net ionic equation for this reaction will be 2 chromium plus 3 carbonate will form Cr2 CO3 3 in solid form. So this one is there. So this is the net ionic equation for this reaction. Now if we go to our second reaction, here the product will be barium sulfate, and barium sulfate is insoluble in water. That means it will be in solid form. And then we have potassium nitrate, and it will be in aqueous form, being water soluble. Now if we want to balance the equation, let's first balance the metals. We have 1 barium in each side, and we have 2 potassium here, but we have 1 potassium here. We have to multiply it by 2. Now we have 2 nitrate here also, and 2 nitrate here, and we have 1 sulfate, 1 sulfate. That means our um, equation is balanced now. Now we have to write the total ionic equation. So barium nitrate will be dissolved as barium ion plus nitrate ion, and then potassium sulfate will be as potassium ion and sulfate ion. And finally, the product side, barium sulfate being insoluble, it will be in the solid form. And then we will have um, 2 of the potassium ions and 2 nitrate ion. Now we will identify our spectator ions here. So here we have 2 nitrate. Okay, so we have 1 barium ion here, but here we don't have any barium ion in the product. That means barium ion is not spectator ion. Then we have 2 nitrate here and 2 nitrate here. That means nitrate is our spectator ion here. And then we have, oh, here we have also 2 potassium, not 1. Now we have 2 potassium here and 2 potassium here. That means this one is also spectator ion. Then we have 1 sulfate here, but we don't have the sulfate in ionic form in the product. So our 2 spectator ions here is K plus, or the potassium ions, and nitrate ion. These two are our spectator ions, and just crossing them from both sides, we can write the net ionic equation, which will be so our net ionic equation will be barium 2 plus will react with SO4 2 minus, and it will produce insoluble barium sulfate. And this is the net ionic equation for this reaction. And finally in C, we have ferrous nitrate, which in aqueous form will react with potassium hydroxide, and the product here will be ferrous hydroxide and potassium nitrate. So if we balance the equation, let's first balance the iron. We have one iron on both sides. Then we have one potassium here, one potassium here. Then we have two nitrate here, but one nitrate here. That means we have to multiply this KNO3 by 2. Now we have two of the K, or the two of the potassium. That means we have to multiply KOH here by 2 to balance the potassium. Now we have two hydroxide, and here we have two hydroxide. So now if we cross check our data here, we have one iron on both sides. We have two nitrate on both sides. Then we have two of the K, or the potassium, on both sides. And finally we have two hydroxide on both sides. So this is our balanced molecular equation for this reaction. Okay, so we haven't written whether our products are aqueous or solid. So ferrous hydroxide is insoluble in water, so it will be in solid form. And KNO3 is soluble, that means it will be in aqueous form. Now I have to write down the total ionic equation. So we'll have ferrous ion and two nitrate ion from the ferrous nitrate. Then we will have two of the potassium ion and two hydroxide ion. And in the product side, we will have FeOH2. It's being insoluble solid, it will be in the solid form. Plus we will have two potassium ion and two nitrate ion. Now we will find out our spectrograms here. So we have one iron ion here, but we don't have an iron ion here. We have two nitrate here and two nitrate here. That means nitrate is our spectrogram here. And then we have two potassium. That means potassium is also expected around here. And so our spectrograms here are nitrate and the potassium. And if we just cut them, we will write the net ionic equation as Fe2 plus will react with 2OH minus to form insoluble FeOH2 or ferrous hydroxide in solid form. So this is the net ionic equation for this reaction.